Imagine it's the year 2124. A student, somewhere on Earth, is sitting in class, learning about the solar system, and their textbook has a chapter that doesn't exist yet, a chapter about the decade in the early 21st century, when scientists discovered that almost everything they believed about our solar system was incomplete. The chapter has a name: The Years We Finally Looked. We are living in those years right now, and what NASA has found in just the last 5 years, in our own solar system, around our own planets, inside our own cosmic neighborhood, should have made headlines every single week. It didn't. So here it is. Something lit up on Jupiter. NASA's most advanced spacecraft was orbiting the planet. Its cameras were rolling. And then, a green glow exploded near the North Pole, moving so fast, it almost escaped detection entirely. Here's the part that should terrify you. That's not even the strangest thing we found this year. What you're about to hear is what happens when we stop treating our solar system like a textbook diagram and start treating it like what it actually is, a place full of secrets that we are only now beginning to crack open. Let's start with Jupiter, and a question nobody expected to be asking in 2020. What is that green light? NASA's Juno spacecraft has been orbiting Jupiter since 2016. It was launched in 2011. Took 5 years just to get there. And since arrival, it has been sending back data that rewrites everything we thought we knew about the largest planet in our solar system. In 2020, JunoCam, Juno's onboard imaging system, captured something near Jupiter's North Pole. A burst of green light. Brilliant. Sudden. Gone in an instant. Capturing fast-moving objects in deep space is extraordinarily difficult. Think about it. Juno is orbiting a planet 484 million miles from Earth. Its cameras were not designed for this, and yet, the image exists. So what caused it? The leading explanation from NASA scientists? Lightning. But not the kind you've ever seen. On Earth, lightning forms inside water-based storm clouds. Friction, ice crystals, electrical charge. Simple enough. On Jupiter, nothing is simple. Jupiter's clouds are made of ammonia and water. The storms inside them are not measured in miles. They are measured in continents. The electrical discharges they produce can create colors we've never seen in Earth's atmosphere, including green. But here's what keeps scientists up at night. We may have been missing this glow for decades. Not because it didn't exist, because our cameras weren't fast enough to catch it. That single thought should stop you cold. How many other things are happening on Jupiter right now that we simply don't have the instruments to see? Jupiter is not a background character in our solar system. It is the dominant force. It accounts for 75% of the combined mass of every planet orbiting our sun. If our planet were the size of a grape, Jupiter would be a basketball. Its gravitational pull has shaped the history of every rock, comet, and asteroid in this system, including the ones that hit Earth, and we're still learning what it's capable of. Now, let's go somewhere closer, 52 million miles away, on average, Mars. In 2021, NASA's Perseverance rover was sitting on the Martian surface. A dust devil rolled past. Scientists expected to record the usual: wind rushing across the microphone, sand scraping against the rover's chassis. Instead, a faint pop. One single, unexpected sound. It didn't make sense. Not immediately. For months, researchers analyzed it, and then the answer came. That pop was electricity, discharging through the thin Martian air. Here's how it works. Mars has no rain, no storm clouds, no lightning rods, but it has dust, enormous quantities of it. When Martian winds drive dust grains into each other at high speed, they exchange electrical charges. Scientists call this process triboelectrification. The friction builds, the charge grows, and then it releases. A spark, not a dramatic bolt of electricity streaking across the sky. Mars's atmosphere is too thin for that. Instead, tiny millisecond bursts. Mini lightning. With this discovery, Mars officially became the third world beyond Earth confirmed to have lightning, after Jupiter, after Saturn. But here's the part that makes this more than just a cool fact. These sparks carry consequences. Electrical activity on Mars can trigger chemical reactions in the atmosphere, producing compounds like hydrogen peroxide and perchlorates. These are the exact chemicals that destroy organic material, the very molecules that might preserve evidence of ancient life. In other words, Martian lightning may be one of the reasons we haven't found signs of life yet. Not because life never existed there, but because electricity has been erasing the evidence for billions of years. And for future astronauts, these sparks won't electrocute you, but they will destroy unprotected electronics. They will corrupt data. They will damage sensors in the exact moments you need them most. Mars is not just cold, not just dry, not just distant. Mars is electrically hostile, and we are only now beginning to understand what that means. Let's talk about the most visually iconic thing in our entire solar system: Saturn's rings. You've seen them in textbooks, in NASA posters, in every solar system illustration since you were a child. They look ancient, permanent, inevitable. They're not. According to research published in 2022, those rings were once a moon. A moon scientists named Chrysalis. For billions of years, Chrysalis orbited Saturn peacefully. Its gravity helped keep Saturn's tilt in check, locked in a gravitational relationship with Neptune, 1.8 billion miles away. Then something went wrong. As Chrysalis spiraled inward, pulled by Saturn's gravity, the planet didn't just capture it, it destroyed it. Saturn's tidal forces tore the moon apart. The solid core crashed inward. The rest, the icy mantle, the frozen shell, the debris, spread outward, flattened, settled into a disk, and became the rings you see today. Let that sit for a moment. The most beautiful feature of the most recognizable planet in our solar system is the graveyard of a destroyed moon. But there's a second twist. When Chrysalis was destroyed, Saturn lost the gravitational anchor that had kept it aligned. It tilted 26.7 degrees off its axis. That tilt you see in every diagram of Saturn, that wasn't always there. A dead moon caused it. And here's why this matters right now. NASA's Dragonfly mission is scheduled to launch in 2028. It's headed for Titan, Saturn's largest moon. A drone helicopter the size of a Mini Cooper, flying through Titan's thick nitrogen atmosphere, landing on alien terrain. One of its goals? Find the geological and chemical fingerprints of that ancient moon collision. If Dragonfly finds them, we will have solved one of Saturn's deepest mysteries. If it doesn't, we go back to the drawing board entirely. In 2016, scientists noticed something wrong with an asteroid. Its orbit had shifted, not by gravity, not by solar pressure, by something else. It was releasing material, like a comet, but it had no tail. No visible gas cloud, no coma. It looked exactly like a rock. It was behaving like something alive. They called it a dark comet. And since that discovery, researchers have identified 14 of them. Here's why that number should alarm you. After analyzing the 7 best-studied dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects could belong to this category. Objects we thought were inert rocks, sitting in stable orbits, quietly drifting, may actually be outgassing, releasing material, giving themselves tiny invisible rocket boosts, changing their trajectories in ways our models didn't account for, moving toward us in ways we did not predict. But the most staggering implication isn't about danger, it's about origin. Dark comets likely contain ice, not on the surface, hidden beneath a rocky exterior. And researchers now believe some dark comets may have carried that ice directly into the inner solar system, to planets like Earth. Follow this chain of logic. 4 billion years ago, Earth was barren, volcanic, bombarded, waterless, and then water appeared. Oceans formed. Life began. Scientists have long debated where Earth's water came from. The most popular theories involve comets and asteroids, but dark comets, objects that look like asteroids but behave like comets, may be the missing link. Icy bodies disguised as rocks, slipping past our detection systems, delivering the most essential molecule for life, without anyone noticing. The water in your body right now, the ocean outside your window, the rain that falls on your city. It may have arrived on something we only just gave a name to. Everything in the Milky Way is moving. Our sun, our planets, every star you can see tonight, all of it, drifting, orbiting, passing. Most of the time, stars pass each other at safe distances, hundreds of light years of empty space between them. No danger, no interaction. But scientists recently ran 12,000 long-term simulations. They asked a very specific question. What happens if a star passes just 100 astronomical units from our sun? That's 100 times the distance from Earth to the sun. In cosmic terms, that's practically a graze. The results were not reassuring. In 95% of simulations, the planets survive. The solar system absorbs the disruption. Life goes on, but in 5% of cases, a chain reaction begins. The outer planets shift first. Neptune, Uranus, their orbits destabilize. That instability sends gravitational ripples inward, like a shockwave through the entire system. Mercury goes first. In nearly half of all unstable scenarios, the smallest planet spirals directly into the sun. Then Venus loses its footing. In some simulations, it collides with Earth. 2 planets, combined, destroyed. And in 23 out of 12,000 simulations, Earth is the last planet standing. Every other world, gone. And Earth orbits alone, a single blue dot, circling a star, in a system that used to be full of worlds. Now here's the detail that matters most. We already know a star is coming. It's called Gliese 710. It is moving toward us right now. In approximately 1.3 million years, it will pass within 10,000 astronomical units of our sun. Not close enough to destabilize the planets, but close enough to disturb the Oort cloud, the vast shell of frozen objects at the very edge of the solar system. Gliese 710 could send a storm of icy comets raining inward, toward the planets, toward Earth. It won't happen in your lifetime, or in the lifetime of anyone you'll ever meet, but it will happen. And the only reason we know it's coming is because we built the tools to look far enough ahead to see it. Here is what all of this adds up to. A green flash on Jupiter that we almost missed. Sparks in the Martian air that may have been erasing evidence of life for billions of years. A moon that died and became the most beautiful ring system in the solar system. Ice-carrying dark comets that may have delivered the water in your body. A star that is already on its way toward us. None of this was in the textbooks when you were in school. None of it was known a generation ago. And here's the uncomfortable truth. We have explored less than 5% of our own solar system, which means everything you've just heard, every shock, every revelation, every discovery, is just the beginning. The universe is not waiting for us to be ready. It has been running experiments for 4.5 billion years. We just started paying close enough attention to notice. So here's the question I want you to sit with. Which of these discoveries unsettled you the most? The lightning that's been erasing Mars's secrets? The moon that became Saturn's rings? Or the star already moving toward us? Drop it in the comments. And if this is the kind of science that keeps you up at night, the real science, sourced from NASA and peer-reviewed research, no fluff, no fiction, subscribe. Because next week, we're going somewhere even stranger. You've been warned.